Now let's look at this figure 7-6. It deals with neutral current flow based upon the amount of current flow in L1, L2, and L3 in the windings of this Y-connected transformer. And notice now we're looking at a three-phase, four-wire connected Y. Now, L1, we have 80 amps as shown in the illustration of the transformer. L2, we have 90 amps, and L3, we have 100 amps. Now, when we place these values in the formula, then we have a certain procedure to follow to determine what this neutral current flow would be. So starting out, we would take the current and square it in L1. The current in L2, we would square. The current in L3, we would square. And then we would minus the current in L1 times the current in L2, minus the current in L2 times the current in L3, minus the current in L3 times the current in L1. Now, when we do this math, as you see, we would have, first of all, 802 plus 902 plus 1002 minus 80 times 90 and 90 times 100 and 100 times 80. Now, when that math is performed, we come up with 6,400, 8,100, 10,000, 7,200, 9,000, and 8,000, excuse me. Now, when we do the math, the plus and the minus, as you said, for each set, we come up then with 24,500 minus 24,200, and then when we get that value, we put it in the square root, which would be 300, and when we do our final math, we'd come up with 17.3. Now, this indicates very clearly that when you have a three-phase system, you usually have very little current flow on your neutral conductor. You know, it's just impossible to go to a panel board, as you see to the right, the service equipment, and balance all that out so it's perfectly even, where you'd have, say, 100 on L1, 100 on L2, and L3, where the neutral wouldn't see any current. That just doesn't happen. So, or I haven't seen it happen. So the solution then, the current flow would be 17.3. Now this is why until the 75 code, we had for a Y system, 122.08, those conductors that you see would be black, red, blue with a white neutral. Then it was a lot easier to balance neutral load. If you had a Y system, then it would be the boy system, brown, orange, yellow, and they used a gray neutral. And that was in the 75 NEC before we changed it. But to correct, we changed it in the 75, so 71 code and back, you know, you would have a suggested color coding of your phase conductors, which we don't have anymore, as you know. So that's what your figure 7-6 is illustrating, how you would determine the current flow on the neutral based upon the current values on L1, L2, and L3.